Hello everyone, welcome back to the channel. So today's session we will cover introduction part of the AWS. Okay, so it's a part of the AWS for beginner playlist. So let's see the introduction part of the what is the cloud computing basically. Okay, so cloud computing is basically it's a compute service which we can use over the internet as simple as, and provider can be anyone like Azure, AWS, Google Cloud, which is GCP, or it might be a IBM Cloud or Oracle Cloud. Okay, so cloud provider doesn't matter basically. The concept is basically we can use their services like storage services, network services, firewall service, monitoring service, or any other services we use by using help of internet, and we can manage from across the world. Okay, there is no restriction basically. And the benefit of using this cloud computing is basically we don't need to purchase any hardware, physical hardware, or we don't need to manage our own data center. Okay, we can just simply open their portal account and we can simply start using it. Okay, yeah. So nowadays most of the organization are trying to move their on-prem data center to AWS cloud or any cloud. Okay, it's basically it has their own benefits. They don't need to manage maintain the own data center, power station or cooling station something, and the data center engineer basically the manpower in short. Okay, so lots of benefits, and you don't need to go market and just get the quotation and purchase the order. Okay, so you can simply you can anytime you can just log into your cloud computing cloud service portal and you can easily manage. Okay, then as a cloud computing benefits, as I just explained, it's there are, you can see the cost saving basically. As I said, you don't need to manage your own data center, and we don't need to manage the or purchase own hardware server. Okay, then we can easily deploy globally. As you can see, we don't need to go to particular location. We can simply from the AWS console or any console we can use and deploy anywhere. Okay, agility and the elasticity. Okay, you can anytime you can simply anytime you can increase or downgrade, okay, your resources basically according to use cases. As part of the benefit of the cloud computing, we can create and manage multiple services anytime. Okay, from the anywhere, and obviously it will save the lots of time and the efforts. We don't need to go to the market and get the quotation from the different vendors like that. Okay, so we can simply log into the portal and we can provision, okay, easily. Yeah, no major manpower and the resource required, because as you can see, we don't, as a user, we don't need to manage our own data center, or we don't need to purchase any hardware, so we can simply use their portal. Okay, then no advance payment required to use services. As we know, in the AWS cloud or any AWS cloud, sorry, any clouds providers, we use as a pricing pay as you go model. Okay, so we don't need to do advance payment for that. After service we use, at the end of the month the bill will generate, and only on once bill generated, only then we can pay the bill. Okay, we need to pay the bill, and we can scale up or down, vertical scaling, horizontal scaling we can do anytime. There is no such a limitations on that, so we can quickly up or down. Okay, the service resources basically according to our use cases, and we can provision resources anywhere in the world in the matter of minutes. As I said, it will save lots of time and efforts on that, so we can easily provision the resources anywhere in the world basically. And obviously we will have a complete control on the infrastructure. We can create, delete, or manage any resources when we need. Let's say today we created one EC2 instance, for example, and tomorrow we don't require, then we can easily delete that from the portal. Okay, but in the traditional way, if you purchase any hardware with the cost of 1 lakh or 2 lakh something, and in that situation your use case is completed, right? Then what will you can do with your hardware machines? You It's a dead investment, right? So these are the some benefits of the cloud computing, the use cases. Okay, as you can see, these are the some pictures for the traditional data center. These kind of racks will there are there basically, and they will maintain the cooling system, power, and all the manpower, by using in the data center. Okay, and let's say for this image basically, if you go to the, let's say in the traditional way, if you want to upgrade any rams or hard drive, so you need to put lots of efforts basically. Okay, so if you want to upgrade your ram, okay, or any hard drive, you know or you want to reduce the ram or hard drive, so you need to shut down your server. Obviously you need to follow the process as org level, like taking the maintenance window, shut down the servers like that, and the approval. And but I'm just talking about the ground level work basically. So you need to shut down the server, then you need to pull out server from the rack. Okay, from this rack, then again you need to open this cabinet, and you need to, this is just an example of blade server basically. This is a type of blade server. So you need to pull out the ram if you want to upgrade or downgrade. If you want to upgrade, then you need to insert the additional ram, and if you want to downgrade, you need to pull out the ram from here, this slot. Okay, and same for the hard drive. So there are lots of efforts and the time consuming process, right? But in the AWS sites, you don't need to perform this kind of activities. You can just simply log into your portal and easily scale up or down. Okay, in minutes of matters of minutes. Okay. Yeah. So these are the some picks basically for the data center. So in the, now we will move to the main topic which we want to learn, okay, by using this playlist. So for the AWS sites, let's say we can, as you can see now in the earlier slides, in the traditional way we need to put lots of efforts, manpower, and all those stuffs, right? But in the AWS side, we don't need to put this kind of efforts, because we can easily log in from the your laptop, your, you know tab or something, desktop or something. Okay, so you can log in from the any media, okay, where it's supported. So let's understand the cloud computing model basically. Infrastructure as a service. Okay, it's basically the, in short form we called as IaaS. Okay, it means that the cloud provider provides the underlying platform, which is, the cloud provider will provide the services like, the storage, compute, and the network service, which while the customer is responsible for rest of the things like patching the EC2 instance, then installing the packages and deploying the applications. Okay, in the infrastructure as a service. Okay, customer is responsible for all the rest of the management. Okay, like create, manage cloud services like VM and EC2 instance, storage service, and the VPC part. Okay, the example of the infrastructure as a service is obviously cloud provider, the AWS, Azure, and Google Cloud. Okay, there might another one, other one as well, but I'm, for the example, I'm just giving this major name basically. So next we will see the cloud computing model is platform as a service, which is we call PaaS. Okay, the cloud providers, the basically platform for developer to create and run their applications using PaaS service. Okay, method. And using PaaS, developer can focus only on creating their code basically. So developer sorry, so basically developer don't need to worry about the underlying hardware or any provisions basically. So they can just simply focus on, as a user we can just simply focus on our application code, basically application codes which we want to manage, and we can simply as a deploy it. Okay, on the platform as a service model. So the customer don't have underlying doesn't have any underlying hardware or resources access to manage. Okay, it basically cloud provider responsibility to manage and maintain the underlying system. Okay, as a developer we just need to put our code and run. Okay, so the best example for this platform as a service is like AWS Elastic Beanstalk, Lambda functions, EKS, RDS, then Google App Engine, like that. So now let's see software as a service. In the software as a service, basically, so in short form is a SaaS. So SaaS applications are running entirely in the cloud base, basically cloud hosted, and the user doesn't need to install anything on this local machine or anything or any particular machine like EC2 instance. The cloud provider basically, they need to manage everything on that way. Okay, we as a user, we just need to use their services. Okay, the cloud cloud provider will handle the maintenance and deployments, obviously. And the best example for this cloud computing model is Office 365, Google Drive, Gmail, Slack, Dropbox, or Cisco WebEx. Okay, and user can simply use of the cloud hosted services. Okay, so for the example, as we already discussed, but just for the summarize for this cloud computing model as an example. So you can see here, as a in infrastructure as a service, you know the cloud provider will manage underlying system and hardware. Okay, and as an administrator, we need to just do rest of the things like creating the EC2 instance, storage services, and manage. Okay, and use it. In the platform as a service, cloud provider will manage this underlying hardware and the applications, basically. And to run this application code, we can simply deploy the code by using this service on the services, basically. Okay, and as a software as a services, we can simply, as an end user, we can just easily use the cloud hosted applications. We don't need to install anything on the machines or something. Okay, that is completely managed by cloud providers. So now coming to the next slide, now we will see six pillars of the well architect framework. Okay, so there are, when we design any architecture in the our project, for the project or org level, so as a best practice or standard practice, we need to follow some well architect framework, basically. Without, if you don't know any such a requirement in the project or any organizations, so how we can create the resources blindly without the proper information. So that is the concept, basically. The provision the infrastructure, and what we need to think before provision the infrastructure. These are the six pillars, basically. Okay, this might be the interview questions for you, so you can just refer this. Okay, the well architect or six pillars, basically, of the AWS cloud. So creating a software system is like a lot like a constructing a building. If the foundation is not solid, as we know from the educational point of view as well, if our primary or secondary education is not well, so we will have some weakness on the communication side or any knowledge side. So same way, if we are building the any house, let's say, and the foundation is not good or strong, so the building will collapse anytime, right? So same concept the use here. The creating any infrastructure or architecture or software system, we need to focus on the foundation, basically. Okay, it should be a proper one, structural. Okay, and the if we ignore these six pillars, then obviously, as I said, if the foundation is not good, then building will collapse anytime, right? So the AWS Well Architect Framework helps cloud architect to build the most secure, high performing, resilient, and efficient infrastructure, right, for their applications. So what are the six pillars for the AWS Well Architect Framework? So when we, as a cloud architect or a cloud engineer, we need to think on this before provision any infrastructure. Okay, in the project. So it's basically operation excellence. Okay, operation excellence, then security, reliability, performance efficiency, cost optimization, and sustainability. Okay, so these are the top six pillars, basically, from the AWS sides. So now we will understand the AWS global structure. Okay, as we know, AWS has lots of their regions, availability zones, local zones, like that. Okay, so till the data I am just collecting, there is a 32 launch regions. Okay, with the each regions has multiple availability zones basically. In the blue dots you can see it's a region, okay, and in the red dot you will see it's a coming soon region basically, okay. So as of now there are 32 already launched regions and 102 availability zones, okay. And then apart from these there are other pops basically, point of presence, which is, and the 13 regional cache which is required for the CDN services or caching the website data, okay. So now to understand the what is the region and availability zones. Regions is basically it can be a particular country or specific location, okay, in that country. So that is called a region, and AWS maintain their regions across the world, okay, in the different locations. And inside that we will see we can see there are multiple availability zones. Availability zones in short form, it's a separate data center, okay. You can see AZ1, AZB and C, okay. So they have their separate data center over there in the each availability zones, okay. And these data center connected to each other with the dedicated lines, and okay, to maintain the failure or well architect. As we can see, if you want a high availability or failure mechanism in our applications, okay, when we design the architecture. So obviously if you are launching 2 instance, right, let's say 2 instance, then obviously we will create 1 instance in AZ1, okay, and then second we will launch in AZB, okay. If suppose something goes wrong with the AZ1, then our application will run from the AZB, okay. Yeah. Okay, now let's understand the AWS global structure, okay. So as we have seen in the earlier slide, there are region, availability zones, and the caching, pops basically, point of presence, okay. So a region is basically it's a separate geographical location, or area. Region consists of multiple physical separated and isolated availability zones, okay, that are connected with the low latency and high throughput, high redundant networking, okay. And availability zones is basically edges. Zones can be a multiple, okay, in the single regions, okay. And it's isolated location within each region. Each availability zone has its their own power, cooling, okay, station basically. Then there are separate dedicated network connectivity, and it's basically a physical data center isolated from each other to maintain the failure for the customers, okay. And as we have seen, pops, point of presence, is basically pops are used for the both AWS CloudFront and CloudFront to deliver content to end users. It's at a high speed, or at the you can see lambda at the edge to run the lambda functions with the lowest possibly latency, okay. So regional edge cache, so what is the regional edge cache basically? It's a caches are used for the CloudFront locations, okay, that are deployed globally close to your viewers basically. When we have a global facing any websites, so we can use this kind of caching service or CDN right over there. So that purpose they require local edge caches data center basically, okay. They are located between your origin servers and the pops, okay. Global edge location that serve content directly to the viewers, okay. As simple as is for the caching service, like that is used for the caching or the CDN service, okay. Now what is the edge location basically? Edge location is the data center used to deliver the content faster to user, okay. This is a part of the CloudFront basically, CloudFront to deliver the data faster by caching the repetitive content, okay, for the faster response. So local zones, what is the local zones basically? AWS local zones are type of AWS infrastructure deployment, okay, that place compute, storage, database, and other services closest to large population, okay, industry and the IT centers, enabling you to deliver applications that require very single digit millisecond latency to end user. Like this is basically for the faster performance. And if you look at the services which the deployed in the local zone, it's basically elastic cache service and the ABS volume and the your load balancer. For the today's session, we will meet in the next section, with the informative videos. Okay, thank you.